Hello there, Tech Graph students. We're going to do an Ellipse cheat sheet today to help you along with your short and long questions. You can see here an arrangement, 6 different things going on. Let's firstly begin by reviewing how we construct an ellipse first, using the concentric circles method. So as you can see here, just taking a minor radius, then a major radius, okay, to produce both a minor and major circles. There's my major axis spanning the major circle and my minor axis spanning the minor circle. Okay. Now, what we want to do is we want to just highlight that that's the major circle, that's the minor circle, and now we're going to use the 60-30 degree method to divide up this circle to produce our ellipse points. So, 30 degrees, 30 degrees, 60 degrees, 60 degrees. Now, I'm going to take the example of this first 30 degree line here, and I'm going to draw a horizontal line from the inside point and a vertical line down from the outside point. And repeat that across all of the ellipse points, okay? And you can see how that works out there. And of course, in later examples, you'll see as well that the points on either end of the major and either end of the minor are actually points on the ellipse as well. Now, I always draw lightly first. When I'm happy with the shape of the ellipse, I then draw it in heavy, okay? And that is the ellipse. Now, let's review how to find focal points on the ellipse.
Okay, so that quick recap from yesterday hopefully has helped you, refamiliarize yourself with the processes and steps and stages involved in drawing the ellipse. As you can see, as explained, went through all the various parts, minor, major, dividing it up, getting our triangles, getting our points, and drawing the curve. Now, the element we want to add in today is what are called focal points. Okay, so focal points. There are 2 contexts with which we look at focal points. The first one would be that they are 2 fixed points that when you attach them to the curve through a series of lines, you will get a constant distance between the 2 points and the curve. And I'll demonstrate that in a moment. Now, that might sound a bit abstract to you right now, but when we see it happen physically, it should make sense. The other way we look at focal points is if we imagine what is called conic sections. That's where we take a cone. Now, you can picture a traffic cone or some conical object, and if we cut that object at an angle less than 45 degrees, we would produce an elliptical surface. And if we were to take the bit that was cut at the top of the cone and the bit that was cut of the cone underneath, and we were to put a ball, like a tennis ball, into the top of the cone, the one that fits perfectly into the cut space, and then one in below, well, those 2 balls, top and bottom, would give us the points of contact with the elliptical cut surface, and they would also be focal points. Now, that's for more leave-insert drawn, and that's something that we would graphically represent more in the questions you would have at, say, leave-insert level. But at junior cert level, focal points, the simple, most abstract way to understand them is that they are 2 fixed points that when we link them to the curve, we have a constant distance that will allow us to actually produce the curve. Okay, so how do we locate these focal points and where might they be? Well, focal points are always located on the major axis, so that's the long axis line. Okay, so this line here that I'm highlighting. And what I do, and this is the trick with it, well, it's not a trick, it's just a method. So I'm going to take my compass, which is probably the most reliable way to do this. Take your compass, and I want you to put the point of the compass at point 0, okay, and stretch it out to the major circle, like so. Now, what we have there on our compass is essentially the major radius, okay? And what we can do here is we can now take the point of the compass and move it to the top of the minor axis, this point right up here. So I'm going to place the point of my compass there, and I am now going to swing an arc to intersect the major axis here, and likewise on the other side. That has given me 2 points, there and there, and they are my focal points, F1 and F2. F is short for focal, and 1 is the first point and 2 is the second point. And just for clarity's sake, if you were to take that major radius and go to the bottom of the minor, you can also swing the points from there and they will align exactly in the same position.
Now let's have a look at some cheats. Okay, let's do it.
Now, so if I connect point F1 to X and point F2 to X, then from there, guys, what we can establish here is that if I measure the length of this line from F1 to X, and I just write in like F1X, and I'll put inside 2 long lines like that, and then if I have F2X, if I add up the length of both of those lines, it will give me the length of the major axis. Now, if I measure my major axis here at the moment, okay, it equals 100. So if I measure F1 to X, it equals 72 millimeters, okay? And if I measure F2 to X, it gives me 28 millimeters, okay? So if we added 72 and 28, what would we get? 100. So F1X plus F2X equals the major. Major axis length. Okay? So hopefully that makes sense to you. Now here's the thing. I could place points anywhere on the curve of the ellipse, no matter where they are. Like for example here, look, I'll do another one. I'll call this point up here, I'll call this point Y. Okay? If I join Y back to F1, okay, and if I join Y back to F2, okay, and I'll just a little bit of a gap here. If I have F1Y and F2Y, okay, if I added both of those together, it should give me the length of the major axis. So I measure the length from F1 to Y. No, I'll have to measure it upside down here. So that is working out at 54 millimeters, okay? Or, yeah, 54. I just want to be sure about that. 54. And then Y to F2 works out at 46. So 54 plus 46, that equals 100 as well, okay? So no matter where the point is on the curve, if we join it back to F1 and F2, we'll always get 2 lines. When you add them up together, will give you the length of the major axis. Now, in a question, you could be given a point Y, you could be given the 2 focal points and asked from there to find the major. That's how you would do it. Join them up, add them together, and that gives you the length of the major axis. And then from there, we can now move into using the point on the curve then to find the other circle. Let's say if we found a major, we need to find a minor. So here we'll just go to the next example. Find ellipse major given minor plus point P on the curve. So what do we do in this case? We use what's called the reverse triangle method. Now we're familiar with that, okay? But we're going to go through it again here just so we're nice and clear on it. So what I'm going to do, I just want to get my marker there, is in this case we have a minor and we have a point in the curve. We draw a horizontal line across from the point on the curve. Horizontal line straight across, and it intersects the curve here. We'll call that point 1. Now if you're thinking back here, point 1, I remember we had a point 1 here when it hit here. Okay, we want to find essentially point 2. Okay, so what we do is from the center point O, we're going to extend out through point 1. Okay, like so. Extend it on. Okay, and then what we're going to do is from point P we're going to draw a vertical line up. Now where they intersect, we'll just put the arrows in. Where those 2 lines intersect, That's a point on the major circle. Okay, so I'll get my compass then, put it on O and measure out to that point. Okay, and then I'm able to swing my major circle as a result, which is a pretty handy tool or method to know. Now, the next one, it says find the ellipse minor given the major and the point P in the curve. So what we're going to do is we're using the reverse triangle method again, but we're going to do it in the opposite way to the last one. This time from point P, what I'm going to do is I'm going to draw a line straight up to hit the major circle. So a vertical line straight up. Then what I'm going to do is I am going to join that point back to 0, like so. Again, I'm putting directional arrows there so we can see what's going on. And finally then, what I'll do is I will draw a horizontal line across from point P to intersect the line we just drew back to the center. So where they intersect, that's the point on the minor circle. So I get my compass, put it on 0, okay, measure out to the point, just be a little more accurate than that, and I can draw, that just kind of moved off a little bit, apologies about that. That's the joys of using the pen and the compass, sometimes it slips out. So now I have the major, now I have the minor, and then for both of these then I could go divide them up 60-30 like I would have for the first one, and I can find my ellipse points. Okay, just for handiness sake, I will just briefly show you the say for example if we were to mirror points to shorten the construction process for the ellipse. Let's say I put in my major axis there. Now I'll just do a little bit of it. Let's say I do a 30-degree line here. Okay, and then I do a 60-degree line. Okay, I then make my little triangles here, here, and drop the vertical lines to intersect. Okay, that gives me 2 points there on the ellipse. Alright, bear in mind that we already have that one, that one, that one, and that one. Okay, now what I can do here is I can mirror them through to the other side. So if I mirror those points, what I do is I take, let's say we'll call this point A, and we'll call this point B. I take A down vertically, straight down, don't worry about the length of the line, and B vertically, straight down. Then you'll go to, get your compass, where that line coming from A passes through the major axis there. Get your compass, okay, measure out to A and swing it around to hit the other side. Okay, now you have point A in its new position. Okay, that's A, and then I could do point B. So where the line from B intersects there, swing B around, and now I have point B. So now I can just join them around and I have half the ellipse, and then of course I could mirror them through the center line going that way. Okay, so that's just on that. Now, next thing I want to do is I want to jump down here to the tangents. So I'm just going to zoom in a little bit down here. Hopefully it'll be a little bit clearer for you now. Okay, so next thing, tangents. Get rid of my t-square there for the moment. I have a point P in the curve. First thing I have to do, if I'm to find the tangent at point P, I need to find the focal points first. So, thinking about the focal points, 0 from the center out to the major, put the point of the compass on the top of the minor or the bottom, swing your arcs, okay, and there we go, we have the focal points located. So F1 and F2. Now what I will do there is I will join F1 back to P and F2 back to P. Okay, in this case I want to bisect the angle that's created there now. Okay, this bisector is called the normal line, and I'll show you how it influences our tangent. Okay, so what I'm going to do is I'm going to bisect. Actually, I'll use my other compass because it's going to be more stable. So from point P, any distance on your compass, okay, obviously within the lengths of both lines. So, and I swing an arc Okay, that arc intersects the line here. We'll call that point 1 and we'll call that point 2. Okay, I can change the distance now, but I must keep it the same for two arcs that I'm going to swing, one from point 1 and one from point 2. I want them to intersect. So from point 1, swing an arc. Try and make that as clear as possible to you at home. There it is. Keep the same distance now. Go to point 2, swing a second arc. If you change the distance on the compass at this point, it's not going to work out properly. That gives me my point 3. Now, I'm going to join point 3 back through point P. Okay? This is called the normal. Okay? And what we do then, okay, and I'm just going to make it a little longer so it's a little more visible for you. Okay? So there's the normal line. And what I do to create my tangent, or you have two ways of doing it. You can use the good old-fashioned protractor. You can put it on point P on that normal line like so and mark 90 degrees. Okay? And you can get a point and draw back through P, and that will be your tangent. Or you can use your set square, line it up on the inside line of your normal tangent line, line the top edge up with point P, and that gives you a right angle line. All in one go. Okay? So, but I think for the use of the protractor, we'll just do that there. So I have the center protractor at point P. I'm going to mark, and I have it lined up on the normal line that I've found, and now I'm going to mark 90 degrees. Okay? So I then take that point I found and I draw back through point P. Okay? Now that is the tangent. Okay? And I'll just put in a little right angle symbol, because the reason why the tangent we're able to find out is because we have the normal line. The normal line is perpendicular to the tangent at a right angle. Okay? So once we had the normal line, we were able to draw the tangent at the correct angle through point P. Okay? And that's the tangent found. Now, moving on to the next one. We have an external point P. Okay? So, this time we're not going to make a triangle. It doesn't work. When the point is outside the curve, we have to use a different method. Now, the first step of that method does involve finding the focal points once again. And you can see how knowing how to find your focal points is really important. So what I do, take the radius of the major, put it on top of the minor, swing and swing. Now, I've got my two focal points now, F1 and F2. And F2. What I do here is, from point P, I'm going to put my compass, needle of my compass on point P, and I'm going to stretch out my compass to the closest focal point. Now you can see focal point 1 is there and focal point 2 is there, and focal point 2 is obviously the one that's closer, isn't it? So what I'm going to do is I'm going to kind of swing a portion of a circle. Now I'm going to do that with my normal compass, because that other one is just sliding a lot. Okay? So I stretch out the compass like that to the closest focal point. And I swing. You don't have to swing a full circle. Alright? I'll just try and make sure it's heavy enough for you to see and distinguish between the rest. Okay? So you see that there. Okay? So essentially, the radius for that is the distance from P to F2. Okay? So, once we have that then, what we do is we take our compass again and we put it on one end of the major axis and stretch it out to the other end. So we're taking the full length of the major axis on our compass. So we take that distance and then we move the needle of the compass to F1. Can you see that there? So I took the full length of the major axis and then I slide the needle to F1. And what I'm going to do here is I am going to swing an arc. Now that arc intersects the circle here. Okay, we'll call that point A. And apologies now, it doesn't intersect the other half of the circle because I'll just have to go back and draw a little bit more of that circle. I thought I had enough of it drawn. Okay, and it intersects the circle here at point, we'll call it B. Now, once we point A and B, we join both of them back to F1. So A goes back to F1 and B goes back to F1. So both of those points, they're connected back to F1. and where they intersect the ellipse, we get 2 points for 2 tangents to come from point P. And in a given question, we might just need one of those. Okay? So in order to draw the tangents, then all I do is I line up P with the point here. We'll call it point 1 here, and we'll call it point 2 here. Okay? So I'll just line P up with point 1, and I'll draw the tangent this way. So we call that tangent 1. And then I'll join P to the point here, and I'll call that tangent 2. Okay, and basically that's it for the kind of tangents. There are other variations on tangents. I don't have, let's say, for another lesson I might do tangents without certain information or certain arrangements of questions the way they might appear in a short question or a long question. But like, that's pretty much it. That really is it. Now there are other things that come in at, say, leaving cert level, like centres of curvature and so on, and we don't really need to know a huge pile about that at junior cycle level. But what we have here is we have our very basics here of how to use our ellipse information as best we can, and I would garner the fact that if you use this cheat sheet while you're trying to solve the short questions and long questions, it will help. Okay, so what I'll do now is I will we'll go back into Classroom. I'll just stop the recording first, and